All right, Unit 4, Lesson 10 homework. All right, so what we're going to do is calculate 864 divided by 27 using an area model and partial quotients, of course. Um, all right, so what we really want to do is, I like the way they had it set up in class, so we're going to kind of do it like how they had it. We're going to start with our number 864 over here, and we're going to have the number it's being divided by up here, 27. So basically, you want to start asking yourself, the easiest way to go about doing these by partial quotients is dealing with numbers, in my mind, the powers of 10. All right? So you could look at this number right here, 27, and you could use powers of 10 until you, what I like to call it, like chunking it out. Okay? Because when I think of partial quotients, I think of us trying to, Bob Marley has a great song. It's called, it goes like this. If you need a big tree, all you need is a small axe ready to cut you down, to cut you down. And the reason I mention that is because these problems are kind of like a big problem. 864 divided by 27 could be overwhelming if you think about it in your head. But let's go ahead and let's try and chop this big tree down with a small axe. We can start doing it by just pieces and pieces. All right, so let's think about it. Hey, all right, let's take a chunk out of 864 by using powers of 10 when we're multiplying by 27. So think about, what's 27 times 10? In your head, you should be thinking, okay, 1 times 27 is 27. It would just add a 0 to that, right? So it could be 270. So how about that? Let's just do that for the first one. Let's go ahead and just take a chunk out. 27 times 10 is 270, right? Times 10 equals 270. So we got our 10 over here. We'll put our 10 over here, because it's essentially like we just took this 10 times 27. We just took a 10 piece out of this whole thing. 864 minus, 864 minus 270 equals 4, 7, 16, 9. So we should have 594. That's how much we got left. Because that's how I want you guys to start looking at it. Look at it like you're chopping down a big tree with a small axe. Okay? So we just took out, and we know for a fact, when we did 10, it took out 270. Let's go ahead and take out another 10. Because this is how, right now we're going to keep it kind of simple. We're just going to be taking out 10 pieces at a time. Just because we're just starting out. In the future, I might have us start thinking a little deeper with it so we don't have to go just 10 by 10. But for right now, let's just do it. 10 times 27, that's going to take out another 270, right, guys? So now, 4 minus 0 is 4. 9 minus 7 is 2. Now, we have 324 left. Do we have enough to take out another 10 piece? I think we do. All right, let's go ahead and take out another 10. All right, 27 times 10 equals 270. So basically, we're keeping track of our answer as we're going down, and we're just subtracting piece by piece, okay? And like I said, since this is our first day, we're just going to keep it just by tens. Just keep it simple, all right? So now, 324 minus 270. So that's 54. So now we got 54 left. All right, notice what we did. We kept taking out chunks. We took out 10 times 27. So now we're up to 30 times 27. After we did that, we have 54 left. So now you need to think, how many times will 27 go into 54? All right, you know the one would only be 27. I think it can go in twice, right? So now let's think about it. 2, whoops, 27 times 2 equals 54. That subtracts our answer. We get 0. So we want to look in here and see exactly what our answer is. In this case, 10 plus 10, 10, 10, 10 is 30, plus 2 is 32. So our answer is 32. Because essentially, guys, what we did was we just kept taking little chunks out. We were like, oh, okay, I don't know how many times it takes to multiply times 27 to get 864, but I know with the powers of 10, I could just keep using those pieces. Take out chunks, take out chunks. And now we took down this big tree and we did it with our small axe. See what I did there? Okay, let's go ahead to the next problem. And like I said, it's the first day we're doing this, so that's why I'm gonna be honest. Like when we do problems in the future, you could easily look and be like, oh, maybe I didn't have to go 10 by 10 by 10. I could see that I could have took out a 20 chunk earlier, or maybe even did all 30 earlier. So as you get more accustomed to like dealing with partial quotients, you'll get more comfy and you'll be able to recognize like, oh, okay, I don't just have to do 10 this time. I can take out a whole big piece this time. So that's the great thing, in my opinion, about partial quotients. Because partial quotients is all about, it's going to deal with your level of comfortability when it comes to multiplication and division in general. Okay? So let's go to this next problem here. Next problem says, survey says, okay, let's see. The next problem, sorry, y'all. Next problem is 476 divided by 17. 476 divided by 17. So we're going to do the same thing. Let's set up. We got our 17 over here. And I'm just going to draw this all the way down. It's almost like our own little box method, really. It's kind of like what it is. So you can use like the box method for like division and multiplication is kind of our way of doing that. 476, we'll put that over here. All right, so now let's think to yourself. 17, let's think about powers of 10. 17 times 10 equals what? You should be thinking 170. Okay, 170 is a nice piece we could take out of here. But it looks like, if you think about it, couldn't you take out more than just one 170? So why not, let's go ahead and take out a 20 piece, all right? And I'm saying 20 piece, maybe I shouldn't word it like that. I like saying stuff like 10 piece and 20 piece because that's how I think about it. Like we could take out a chunk of 10, but a chunk of 10 is only going to take out 170. So why not take out a chunk of 20? Let's do that on this one, okay? But the good thing about partial quotients is if you like, you could just stay with chunks of 10 the whole time, all right? But we're noticing that this number is bigger, so let's go ahead and think about it. I could take out a 10 piece, but let's go ahead and take out a 20 piece. Work smarter, not harder, okay? So 20 times 17, 2 times 17 equals 34 plus 0 is 340. So now we're able to take a bigger piece out. 476 minus 340 equals 136. All right? So the coolest thing, again, I'll say it again, about partial quotients is it's so cool because you can go at whichever level you feel comfortable. Okay, if you wanted to, you could just keep taking out the smallest piece, smallest piece, smallest piece, and get down to however you want to do it. All right, so 20. How many times will 20 go into 36 without going over? That might be kind of hard to figure out. So let's use what we do know. We don't have to get it all in one whop. So let's think about it like this. I do know I do know that if we did another 10 for 170, it would be too much, because 10 times 117 would be 170. That's not going to help us out. What if we took out a 5? So let's go 5. Let's see what we can do. All right. We'll do a 5 over here. 5 times 17. And you should know 5 times 7 is 35, plus 5 times 10 is 50, so it's 85, because you did 50 plus 35. Oh yeah, I shouldn't even have. Oh. I made this, 17. Yeah. Alright, well, we'll do it like that. I made it a little harder than it needed to be, but we'll just do the 5 piece. Sorry, guys. 85. So 1. And that's going to be 51. So we got 51 left. Alright? Because this is what I want you to do, is I want you to start thinking by powers of 10. So we did powers of 10, but we just took out 20. So we did the 10 plus 10, it gave us 20. Now, that power of 10 wouldn't have helped us here. So we did a 5. So what we got left? Now we got 51 left. How many times will 17 go into 51 without going over? 17 times 2 is 34. 17 times 3 is 51. So now let's make sure. All right. And my apologies, I made that one a little harder than I needed. Well, not really. I did it exactly how it was supposed to be, but all right. So basically, y'all, partial quotients. Because in the end, we could have just did 10 times 17 and got 170, but that would have took out like a little piece. So we did 20 times 17 and got 340, subtracted that. So imagine this. This is literally our big tree, and we're chopping it down, okay? Chopping it down. All right, now I want you to apply these same strategies that I use to answer these last couple problems. For the people who they're going to tell me, oh, I didn't get the homework paper. These are the last 2 problems. These are the problems I'm checking for in the morning. 814 divided by 22. And the last problem is 504 divided by 18. And you're going to use this area model method for the rest of those problems. All right?